give you a brief overview. It's a Haskell library that I worked on with Sjoerd, who is also in the room over there. Published it, I think, a couple years ago now. But I'll give you a brief overview. It's a library that allows you to express conversions between your own Haskell data types and JSON, both ways. It's available on HaskellX, so you can play with it if you want. I'll show the link later. So it's built on top of JSON, which is probably the most popular JSON library available for Haskell. If you use JSON and it'll give you nice generic conversion behavior out of the box. But if you want to do anything special, then JSON says write your own conversion to and from JSON. So the example in the documentation is we have a data type with two fields, name and age, and you write your from JSON instance where you say, if I parse a JSON object, I'm looking for these two fields in a JSON object, and I'll wrap it in a person constructor. And any non-object we will fill. And the other way around is if you have a person value, you wrap it in an object. So the problem with this is you're basically writing the same thing twice. Because if I show you parse JSON, you can write to JSON, and the other way around. So what I wanted to do is, if you want to deviate from the standard generics approach that JSON gives you, but still you want to, if you want to deviate from that, can you write this in one go? And the answer is yes, and that's what JsonGrammar is. So here's the same example, but then in JsonGrammar. There's the same data type. The first thing you do is you use some template Haskell to derive a prism. Prism is a special type of lens. Basically what it does is it converts between a wrapped data type, so the person constructor, and its fields in both ways. And obviously if you have multiple data types, multiple constructors in your data type, then unwrapping it can fail if you're expecting one of these specific constructors. So there's some failure built in as well. And then this is what the instance looks like. It's no longer called to JSON or from JSON because you're doing both directions at the same time. So the library calls this a grammar. And what you write here is, I'm looking for a JSON object with two properties called name and age, and which you give as arguments to the object combinator. And then you say, use this prism to wrap or unwrap the two values that you extract or produce, because all of this is bidirectional. So you can read these descriptions, you can think of them as parsing or as serializing them. So how do you actually use this? So there's two functions, which if you give them your grammar, they turn into type signatures that you already know or familiar with if you've used JSON before. So if you say parse my grammar, then you get a function from JSON value to an JSON parser that produces a person when you run it, which is what you typically do in JSON. And if you say serialize my grammar, then you get a function from person back to a JSON value. The nice thing is there's enough information in this grammar that you can do some extra stuff as well. You can have an extra interpretation. So what the library also gives you is a way to extract TypeScript interfaces. So for those who haven't seen TypeScript before, it's a superset of JavaScript with some type annotations, and it compiles to JavaScript, plain JavaScript, doing some type checking as you go. But to do the type checking, you need some interfaces that give the compiler extra information. So you don't get it entirely for free. What you need to do is you need to label your grammar so it knows what name to generate for your TypeScript interface. And it looks like this. It's pretty simple. I'll show you a small extra example. There's some small sophisticated things going on. For example, if you say the age property is optional, the diamond operator is the append operator for monoid. So this says expect or produce a property called age, or use default value of 42. then the TypeScript interface is adapted accordingly. So the age property is now optional. You see the difference in the interface that is generated. So let's dive a little bit deeper into how this works. And the best way to do that is to show you some of the types. So if we take the JSON instance, yes, the first thing I should say is the dot is the normal dot from the category theory, category type class, which I've specialized here for grammars. So you can see there's 3 type arguments to grammar. There's some sort of context, which I'll explain about in seconds, and then the 2 standard category arguments. The type of the grammar that is being generated is a value grammar that converts between a JSON value and your own data type, your person data type. So remember, this is bidirectional, so you can read this in either direction. Either you're parsing and then you go from left to right, from value to person, or you're serializing and you're going from person to value. And the way that the dot operator works, and the thing that makes it all nicely compositional, is the fact that we use stacks of values in the types. So it's not just a value in the person, it's a value, cons, some other stack that we don't really care about. So the T is polymorphic on purpose. So you should think about this as, if we're parsing, pop a value off the stack, parse it, and then push the resulting person back on top of the stack. Or the other way, pop a person off the stack, serialize it, and push the ASIN value on top of the stack. The prop and objects work like this. You give prop a name of the property that you're looking for, and it'll give you a grammar in the object context. And if you're parsing, you go from T to a const T, which means I don't really care what's on the stack. I'm just gonna look up the property in the object that I have available in the current context, the name you've given to me, and I'll parse it according to the JSON instance for A, and then I'll push the resulting value on top of the stack, and the other way around again. And then there's object, which takes an object grammar. Then the object grammar describes how to parse properties or serialize the properties, and it says I'll turn it into a value grammar for you. And you can only compose with the dot operator and the diamond operator. You can only compose grammars that are in the same context. Let's see. So, right, and the last bit is the prism. So the person prism gives you a grammar that works in any context. So context is polymorphic here. And as you can see, it converts between the fields of the person and the wrapped person version. There's something similar for arrays, which I haven't shown in the example, but it works very similar to properties, except it works in a third and final context, which is the array context for grammars. But the rest of the types are very similar. So the last thing I want to highlight is JsonGrammar doesn't make any assumptions at all about the shape of your JSON or the shape of your Haskell data types. So they can be completely different, or you still want to serialize and parse them, right? So they should be somewhat similar, but they don't have to have exactly the same shape. So for example, here I've extended the person data type with 2 extra fields, lat and long, and I'll show you 2 different ways of serializing them or parsing them from and to JSON. So here we say, okay, I want 2 extra properties in my JSON object called lat and long. And an alternative definition is I'll have 1 extra property, but the value of it is an array of 2 elements. And these are both type correct implementations of the grammar that will result in different JSON representations for the same data type.
Question?
Yes.
Is there something positional going on here? Right?
Yes.
If I swizzled around the order of the...
Mentioning that, I was gonna say that. So indeed, the name and age property, they are in the same order as in the constructor. But so you want to match those to your Haskell data type. But obviously, since you're parsing objects, it doesn't have any effect on the order of the fields in the JSON representation, because there's no order specified there. Yes. About this is L and prop all push or pop one value on or off the stack, and it'll be, when you write it down, it'll be in the same order as your data type, as the fields in your data type. All right. So that's.
Can you apply arbitrary ISO?
Yes. So from Prism allows you to lift any Prism, so it doesn't have to be a constructor deconstructor
So for
pair.
example, if I wanted to swap these two array elements,
Yeah, you could write a a stack manipulator that swaps the two elements. So that's what I wanted to say. Like I said, the code is available on HaskellX and on GitHub, and I'll be happy to take any questions if anyone has questions. Yes.
there's this abstract data type of grammar, but you haven't told us anything about how it's implemented.
Yeah.
What's the data type or the declaration for grammar?
I think it's called a deep embedding. So it's basically a JDT that directly matches the functions that you use, and then there's 3 interpreters. So one that parses, one that serializes, and one that converts to.
Can you show it to us by following one of these links?
Yes. Well, I won't follow it. I'll just show you the code here. Oops. So here is a GAT. Oh, sorry. Here we go. All right. This is better. So this is a GAT. So you can see the identity function, dot operator from category are there, and the 2 monoid functions, and then there's pure, which is slightly more general than from Prism, but from Prism is interpreted in terms of pure. Then there's many, which is more like a fun exercise. It works, but not super useful, I think. There's a way to lift literal values into the grammar. You can label them, which is only used for the TypeScript definitions. And there's object property, array elements. And coerce is, again, something that's only useful for the TypeScript interfaces. So it's not to do anything with the JSON representation or the Haskell representation. Does that answer your question? Yes, another question.
What's the value column minus t? What exactly does that mean?
Which constructor are you looking at?
The stack column, the 5-level stack column.
Yeah, so are you talking about a specific line that I can?
Well, for example, line
50, right, okay. So the second and the third argument of the grammar type constructor are the 2 shapes of the stacks before and after transformation. So when you're parsing, you should read it from left to right. You're going from value on top of some stack to that value no longer on that stack, but leaving the rest of the stack intact. And when serializing, suddenly a value appears on top of the stack.
So we should think of it as a type level list, right?
Yes, it's like a type level H list kind of thing. Yes. I can also briefly show you the implementation of the. Sorry, I have to look here. Slightly confusing. The parser. So the parser, there's 3 versions, 3 parses depending on the context argument. So there's a parse value for grammar value and the parse properties for grammar objects. And you can see an extra argument, which is the context that is needed to fully implement the object parser. But it translates directly into the ASIN calls that you would write by hand otherwise. Do we still have time for another question? Or?
Yeah, for one more.
Okay. Are you thinking? So I can imagine, for example, deriving or generating a JSON schema in the same way that I'm now generating a TypeScript interface. But I chose for TypeScript because I think it's more popular. As far as I know, JSON schema is not very widely used anymore.
I thought about doing this, but
Supporting the grammar GDT. Okay.
from my perspective, that is part of the API. I would like to.
Right. That makes sense. Yeah. All right. Thanks.
I think there was actually one more. Simon, would you have another question?
So the prisms only wrap or unwrap constructors, and think about them as a more specific version of the pure type signature. So it has two fields, and they're both directly corresponding to what JSON expects. So the first one is T1 to a parser of T2, and parser is the JSON parser. And the other one is T2 back to a maybe, which is the serialization direction. And your prism is just a specific call of this constructor for a constructor rep and rep pair.
So are you effectively just using the template Haskell jiggly pokery inside the lens library to generate some boilerplate code?
That's right, yeah. That's right, yeah. So it's pretty boring code to write otherwise, but it's not specific to JsonGrammar, right? It's more generally useful. So it's also in its own library.
Okay, thank you.
Thanks very much.